over our grapple manufacturing. I'm Ryan Perkins.
I'm Colin Baldwin.
I'm Joseph Rendon.
We had to define the problem, and the problem is to come up with a grapple that can compete with other grapples using syringes to operate the hydraulics. And the grapple has to be able to pick up different objects in a certain amount of time and place them in a certain area.
So we brainstormed. We all came up with a little bit of ideas, and we all decided on going with one design.
And here's some pictures if everybody would like to look at our pictures. Instead of looking at your computers, would you please look at our PowerPoint, please? Alright, we also had to do some research to generate ideas. We looked at different websites to do the majority of our research. In these websites, we saw different grapples that looked similar to the one we were wanting to design. When researched for claws with similar characteristics as ours to improve our design and make it much more effective. And there's some of the websites we used and a couple pictures that we based ours off of.
We had to identify the criteria and the constraints, and we used the 1200, the U-print model 3D printers, and the model and support material must stay within an 8x8x1 printing area. Students will be provided with support and model materials, string, and glue. No other materials will be allowed. Each grapple must have a drive and driven syringe with a 3-inch or 3 foot of air hose to complete the hydraulic system. Each grapple must have a designed place to attach a syringe or designate. The grapple must have a physical attribute that allows for the grapple to be connected to the crane. The objects that the grapple will pick up will be determined on the day of the challenge. You must design a grapple that is multi-purpose. During the challenge, the group members are not allowed to communicate with one another, and each team is given 90 seconds to complete the challenge, moving objects from one side of the table to a specific target zone on the other side of the table. The team who successfully moves objects from one side of the table to the target zone on the other side of the table will be the winners of the competition.
So we explored our possibilities. The pluses of using was a 3D printer, so we could make a bunch of different designs possible, and we could design it any way we wanted to. The negatives were that we had to make it to lift up multiple objects, which if we only had to lift one certain type of object, it makes it so much easier. We had time constraint, and we had to have size constraint with the 8x8x1, and we didn't have much experience using our remember.
Okay, this is our approach that we selected. The approach we used in creating our grapple was first to generate ideas. Once we came up with our ideas, we started to draw what we thought would look like on Inventor. When we started designing our claw, we first designed the claw. We thought we wanted circle parts, but we ended up going with squares on the top pieces. We chose to make them squared so they would be stationary and wouldn't move freely. We put pins in so they would help guide the claw back and forth without having to dislodge the entire piece. We designed the claw and made a glass case that was 8 inches by 8 inches by 1 inch, which was one rule we had to follow. We printed the grapple and took an estimated 12 hours to print, and once it was printed, we bathed it to get rid of all the excess structure off, and we conjoined the pieces, and we started to test it and evaluate to make the necessary changes that we needed for the claw.
The develop and design proposal. While brainstorming ideas, we decided that we wanted it to be stationary instead of moving freely. We did this by putting square tops instead of circular. We made little pins that would allow the 2 claw pieces to be guided on. In the middle of one of the claws, we put a beam that would allow us to attach the grapple via bolt to the crane. Our point of emphasis was the claw, and we decided that it would be beneficial if they didn't overlap each other, and we offset them just in case they would have to overlap each other somehow.
So all our pieces had to fit in an 8x8x1, and we were able to put everything together by using a bolt, string, and our printed material. We attached the dry part of the hydraulics to the grapple so we could move it by that. So we made a spot on our claw to attach the crane and had no problem attaching it.
So then we had to test and evaluate our testing. We tested our grapple many times to work out the bad and make it even better. In testing, we had to decide which way it was going to work better with the syringe on top or on the bottom. We ended up putting it on the top. We decided to put it on the bottom due to giving us the best advantage, but we actually ended up putting it on the top because once we evaluated it again, it ended up needing to be on top because it would work better that way. When putting it on the crane, it seemed to work very well with picking up objects. We tested it on many different objects, including glue, cups, and some keys. We were able to pick them all up and place them into a different area on the table. Evaluating our work in the practice gave us great confidence in the grapple we created.
And the refining process, there were some places on the grapple that we needed to correct and improve before we could call it a final product. One area was the guide pins. When we first made them, we wanted them to be small so it could slide easily on them and not get bound up. We came to find out we needed to worry more about the support than the building or the binding. So we had to remake the pins at a bigger size, which would allow free sliding and more support. Another area we had to rethink was how to attach it to the crane. At first we thought about string, and then once we started practicing, it seemed to work better with just attaching it right to the bolt instead of attaching string to it as well. We made these adjustments and we now have the final product.
So the process of making this was crazy fun and time-consuming project. We started with the ideas by drawing it from inventor and then actually printing it on the 3D printer. In creating grapple, we had to meet the criteria and constraints that we needed to have a successful and competitive grapple.
And in communicating our results, the grapple project was a good team-building activity. It started as different individual ideas and combining them to make the best grapple possible. With the practice time we had invested into this and the objects we practiced with, we believe that we will be able to meet the criteria and constraints to this project. The drive and driven part of the hydraulics was put into great use within the grapple. We believe we can move objects within 90-second time period. We hope to complete and surpass the rest of the grapples and have no unwanted mistakes within the grapple design itself. Does anybody have any questions?
Yeah, I do. What would you have done differently now that you've competed, you've seen the rest of the groups? What would you do with your piece to improve upon it at this point?
I think it probably would have made it where it opened up a little bit wider so we didn't have to grab that apple like how we did. We could have went straight over the top of it and made it a little easier.
But as far as the guide pins, anything like that, you would stay true to that?
Yeah, it worked pretty well.
I thought it worked great. Yeah, I absolutely did. I think you were limited by the syringes on the travel. I don't know if there was one in there that would give you a little bit more travel, but yeah, I thought the functionality of it was really pretty good.
Any other questions? That's our presentation.
Thanks, guys.